Alright, so after seeing the model, now let's look at all the different parts and how I got them. So here we have all the brushes, this holds the brushes, and this is 3D printed with a 0.2 millimeter layer height, and I used a brim and an 80% infill, and it has a grid infill. Here is all the parts that are going to hold the cylinder, and here's the PVC cylinder, and this has another 80% infill with also a 0.2 millimeter layer height, and I did an 8 layer brim on the outside of all those parts to help them adhere to the print bed. Then over here, this has a 0.17 millimeter layer height. I used a tree support for some of the supports because it's usually the easiest support to remove. And this has the flywheel and the flywheel stand along with the commutator 3D printed part that's going to hold the commutator along with the crankshaft. I'm sorry, yeah, the crankshaft. Now here's the piston. Here's the piston, which was printed with a 0.1 millimeter layer height, a very fine layer height. And here is the part that connects the piston to the connecting rod. And that is printed also with a 0.1 millimeter layer height, and that snaps in there and will bolt in later. Now we have other parts that weren't manufactured because I couldn't make them myself, such as the carbon brushes and the ball bearings that are going to be holding the 3D printed parts, the FDM 3D printed parts together, along with the M10 nuts, which is the counterweight inside of the flywheel. I also have the actual copper piping, which I'm going to be using for the commutator, and that is also purchased and not made. Okay, so now we have all the inserts and pieces put together for all the plastic 3D printed parts. We have the carbon brushes put in. You can see all 4 of them here. Then we have put all the M10 nuts inside of the flywheel. And we have also put the magnets inside of the piston. So now we have all the metal fittings in there, and we also have the bearings inside of the coupler link or the connecting rod. So now we have to move on to assembling all these things together now. Alright, so here it is, finally put together. I just finished soldering all the wires that go from the commutators to the positive and negative terminals that are rotating on the shaft. I have everything mounted on this piece of wood, and I have wound the solenoid right here. I have tried hooking it up to a power source and running it. The biggest problem is that there's too much resistance inside of the they won't keep it running, and I'm going to show you what happens if I just connect it to one terminal at a time. So this is the one. Here's one terminal. Connect to the other terminal. See how the motor wants to work. It wants to repel it there, and it pushes it back. So that the magnetic field's working pretty good to keep pushing it forward and backwards. But the biggest problem is the resistance of the brush assembly, the commutator brush assembly. For example, if I probe, I don't know if you guys can see, but here I'm going to try to show you. If I probe across, here's the resistance. It's 25 ohms, 26 ohms. I even had it go up to 40 ohms in some spots. There's 28 ohms. Now if I probe across these wires here, go about to like 2 ohms. There's 1.8, 1.9. It's just about 2 ohms across the whole solenoid. So that means that there's an extra like 27, 26 ohms that's produced through the commutators, which makes it so much resistance that it can't run off of this little 12 volt battery charger, which is DC. This is DC, so that's not the problem. Which, as you saw, I used the DC to pull it in. It wasn't making oscillate. So the biggest problem I'm having now is making a lower resistance commutator thing. So I'd have to redesign that somehow or make it better. That's all I have for now.